we've already talked about circularity, and that's where we've been built from the ground up. And probably the easiest one to use is, I'll use an example. Again, surgeon's gown. I think everyone can relate to a surgeon's gown. We all know what it looks like and everything there. So if we have a look from the start, we look at the product and we look at the performance of the product. So the product has to perform to the medical device regulatory standards. Now, one of those standards, for instance, is fluid resistance. And for fluid resistance, that requires fluorocarbons at the moment, or otherwise known as forever chemicals. So one of the really exciting projects we're working on with Denmark, so with the Danish Healthcare Authority, is producing the world's first system for forever chemical free, or PFAS, fluorocarbon free coatings on them. And there's some really big challenges. We've got textile and chemical manufacturers we're closely working with to get systems which will do this. This is systems that can maintain water resistance despite being washed, being dried, being sterilised, being used in a clinical setting, and then going through that a target of 100 times before it gets to the end of life. So I think that's been an important thing. The other thing to think about with the product for what we're doing with reuse is the logistics. How do we decrease the logistics footprint? So for instance, using electric vehicles, but then again, using things that are close to site. So you're talking about you've got your big facility where you have to use some gas to do it. We're looking at what's the smallest facility we can make but still make it commercially feasible. Because we do know the bigger the scale is, the more efficiencies you can get in, because you get people and machines, you can invest more into machinery, all working together nicely. But we're looking at what's the smallest we can get it, so we can actually have digitally networked hubs everywhere, so we can actually, what that provides is resilience. And also with digital, you can actually learn from each other as well, and everyone can be networked, and you've got less to travel. If we have some sort of disaster, natural or unnatural, you can still get that resilience and keep that local supply going with these close hubs, and decrease all that transport cost. And then after logistics, you get to end of life. Now, traditionally, when we started in the textile laundry industry, the best practice was incineration for waste reclamation. Otherwise, it got incinerated and went to landfill. In the worst case, macerated and put down the drain. And this is for a reusable. Now people are looking at recycling and repurposing. So some of the work that we're doing, for instance, with Nottingham Trent University, we're looking at how do you take a surgical gown, at the end of the life, how you do then turn it into an endoscopy gown. Then at the end of its life, how do you then turn it into a patient's gown? Then at the end of that's life, how do you then repurpose it to something else? And then when you come right down to the end of that, how do you recycle it most efficiently? Can you do a textile to textile recycle? Yes, you can, but you'll still get off waste. So we've been looking at technologies to keep it in the system where we actually palletize everything and then form them into hollowware or bowls that are used in the operating theatre that can still be sterilised using the same material. And that can be reused and again. So actually keep that material in the system the whole time. But we must remember that recycling is not the answer. There's a big energy. There's a big energy use. There's a big resource use for recycling. So keeping that circularity, keeping that balance, and keeping those key things in place: product performance, product logistics, the repurposing, and then the recycling, but keeping that all in balance.